So I am rather quickly going to build a data warehouse using our sisula ETL framework. And to have some data to work with, I've downloaded this PGA tour data from Kaggle. If I scroll down a little bit here, you can see the contents of the data. It's some statistics from the players. So you can see the file, it's down here in a folder that I've created, it already downloaded. On top of that, we're going to need the actual ETL framework. So this is open source and available on GitHub, so I'm just going to download this into the same folder. I'm going to save that there. It's very small, so it's really quick. Now we have the framework there. I'm going to unzip this. This actually unzips into a folder, so I'm going to just remove the path, extract it, and there it is. I don't know why it actually does that, but it actually removes the sizing of the windows that I've set up so nicely. So I'm just going to move that back there. I'm going to open this here because we'll be editing some files. So let's go back there. It's the framework folder, and here it is. The framework comes with an example, and it's contained in the example folder. So we'll be using this as a template because it's going to save us some work. So I'm going to copy this and we're just going to paste it somewhere here. So we get a new folder, and we're going to rename this one to golf. So this will be our new project based on the same structure as in the example. So if you look at this, you will see that there are a number of subfolders in the project. One of the most important things is this small file called variables.bat. This is where we set up the names of the databases and other things that will be automatically substituted when we generate the code. So I'm going to change this. I'm going to change the source to, say, Kaggle, the system to PGA, target database. The target database is where we have the normalized data, and in our case it will be an anchor model, but it doesn't necessarily have to be that. So I'm going to call this the golf data warehouse. We're going to use the DBO schema. We're going to have a staging database. This is where our files will end up after being loaded. I'm going to change and use the same schema here. Normally I would use one schema per system or source to actually keep things separate. When you have a large data warehouse, that actually helps a lot. A metadatabase, when you run the framework, there will be some data that it's capturing along the way, how many inserts it's doing, what files it's seen, stuff like that. And we need somewhere to put that. I usually put it in the same database as the data warehouse, so I'm going to put it metadata alongside it. So now that file is done, but we don't have the databases yet, so I'm going to create the databases here. So I'm going to do a new database, golf DB. We'll just keep it as it is for now. And a golf stage, like that. In a real world scenario, you would of course adjust sizes and growth and stuff like that. So now we have the databases, so there's somewhere for the data to end up. The metadata needs a model in which to store the metadata, and the framework comes with a metadata model. So if you open the metadata folder, there are some scripts that you run in order to install this schema in the database. I'm going to open it, and now I'm in the wrong database. I'm going to golf DB, execute, and create the model, execute, and we're going to insert some values into the knots. The metadata is of course an anchor model in itself. Create logging procedures. These are the stored procedures that are called when you run jobs within the framework that actually store the data into the metadata model. So now we have all of the stuff in place. So if you look at the golf data warehouse, there should be some views and tables that you can start to work with once you have data. The golf stage is of course empty, so the next step is to actually try to get one of these files in there. So I'm gonna extract this one, the PGA Tour data, and we get a new folder in which this is over here. I'm gonna close that one. There it is, and it's a CSV file, about 1 gigabyte, 928 megabytes of data. So we'll have a quick look at what the file format is. We'll go back to the Kaggle page. We would expect like player name, date, statistics, variable, and value. Statistics is sort of like a grouping of these variables that have some sort of value. And this is what the file looks like. Just gonna make a quick check because in golf, yeah, you can see here are some golf scores, and I'm just gonna check. Yeah, so this is not a numerical value all the time, even if it looks like it. It's can actually contain other characters, so we're gonna use like a character data type to store this. Also gonna check if there's any quoted identifiers. Sorry, yeah, there is. Then it's a quote here because this name here contains a comma sign. So this, in order to not confuse it with the comma separator, this is it uses the quoting here. So we need to take care of that when we load this file. So the first thing is, now that we've seen the file, is to actually use this as a specification to describe the structure of the file. So the metadata for what a file looks like is found under sources. I'm in the golf example here, so this is still the copy of what was found in the other example. This other example uses regular expressions to split the data. It's really powerful, but it's slightly slower than the bulk. But you can work with files that have very exotic formats. We're not going to do that because this is straightforward comma separated values. So I'm removing some of the things that we don't need here. So first, I'm just going to close that as well. So the first row 1, no, 2, because there was a header in the file that we're working with. I'm not going to use the regular expression splitting. I'm using bulk loading instead to do that. None of the rows will be larger than 1000. I happen to know that on Kaggle it's always Unix terminators, so I'm going to remove the R there. It's not a Unicode, it's an ASCII file. Code page is probably correct. So now I'm going to add the stuff I need for the quoted identifier. So I'm just going to type format CSV. These are the same things that you would specify for the bulk insert command in SQL Server. So these attributes actually correspond to options for that command. So next is field quote, and I'm going to use a double quote as the field quote. So let's just call this stats, and we have some terms. Oh, I forgot. I should have copied that. And just so we know what we're working with, I'm going to put that there. So the delimiter in this case is a comma sign. So I can add a comma there. And it's player name. And the format is not an integer. It's, let's say, a varchar 555. So we're going to need a bunch of these. I'm going to remove all of that stuff that we have there. Player name, date, statistic, variable, value. The date certainly looks like a date, so let's assume that the date actually is a date, so we can do a date like that. And we have statistic, which is also some sort of string value, and the variable, also a string value. And finally the actual value, which is also a string, like that. But the final one is not delimited by a comma sign, it's the end of the line, so I'm going to remove the delimiter of the final one there. Then you can actually define some sort of key here, so I'm going to call this the stat key, and it will actually check for duplicates among the rows that you have if within this key. So let's see, the key in this case is probably a combination of player name, the date, the statistic, and the variable. So the same statistic can be measured at different times, then we would have different dates. So I'm going to actually put that date at the end. It feels more natural like that, sort of. And probably we're going to view it like that. So we're interested in, probably more interested in some particular statistic. Doesn't really matter in this case because it's just checking uniqueness. But anyway, it's nice to keep things in order. So now we have the source defined. The next step is to actually move this file, or copy it anyway, to the place where it should be. So I'm going to move this into the golf project here. There's a data folder. In this one there's an incoming folder. I'm going to put this here. This is for the old examples. I'm going to delete those files. I'm going to add this new file here, which is this the one that we specified. Once the framework is running, it's going to be moving this file first to work. If everything then is okay with loading the file into the database, it's going to be moved to the archive afterwards. So, but it will be an incoming first. Next is to actually set up the job that will actually do the work for us, and then we need to go to the workflows. In the workflow folder there's an example workflow here, XML file as well. So one of the things I'm going to change here is this example. It should be golf instead. The path to where it's going to be looking for the file. I'm going to change all of these to golf. And here you can see it uses a regular expression to match the file name. I'm going to remove that because I'm just going to grab any CSV file in that folder. And we're almost done. The only thing that we need here is to actually switch which job it's running in this particular location, because now we're not using the regular expression splitting, we're going to use the bulk instead. So I'm just going to uncomment that instead. So it's using the right job at that step. And actually now we're pretty much done with setting up the metadata. So I'm going back here. Going to go into the sisula folder. Now we need to install this into the database, and the way this is done is by running a command called sisulate. So if I just run this by itself, it's going to show its syntax. So I'm going to point to a folder, and it's the golf folder. This works with a network path as well, but if I do it like this without any other arguments, it's going to do a dry run of the actual installation. So now it's just generating SQL files, as you can see here. So if you want to just generate the SQL and inspect it before you do anything else, you do this type of dry run. If you want to install something, you also need to add the database in the name of the database server. So in my case this is warp. And going back here, you can also see if I want to specify some parts that it should install rather than everything, I can do a final option called filters. And now I'm just interested in the sources and the workflows. So I'm going to add /sw at the end. Oh, SQL Server is not running. So let's start SQL Server agent. Sorry, the agent was not running. It's the job agent. Should have seen that. It was a little red dot. So now it's up and running, I hope. It's still a red dot there, but let's give it another try. All right. So some of the things that should have happened now is that we should have gotten in the stage database some stored procedures that actually load this data. And as you can see here, we have some stored procedures that were created, and these will be run by the job that I also created here. Oh, I have some other ones left over from some other attempt of this. Okay, so there's the staging job. There was a loading job also, but we're not going to do that. That's for later when we want to load from stage into the normalized model. But here's the job. Let's start it and cross our fingers that everything runs as it should. So this will actually call these stored procedures that will load the data into the database, check for duplicates, add the keys, things like that. And the file was rather large actually, so this may take a little while, particularly since I didn't set the growth very high on the database. So while it's running, we can actually have a little look at what this job is doing. So looking at the steps here, it's gonna check for and move files. So that's the first step it's doing. So it should have moved the file now from the incoming folder. As you can see, it's now empty, and it's putting it into the work. Oh, it's even gone from the work. So the first step, the bulk insert, is already done because it's now in the archive folder instead. So and then it's gonna split this up into some splits and create some views on this, create a typed table. So it's all, the bulk insert is always starting by reading the raw data, and afterwards it's actually putting this into a table that has the data types that we specified. This is because it needs to be able to do, if you want to, error checking on the raw data. And after that it's going to add the keys, and then the job is successful. So we can actually open the job activity monitor, and let's see if we can see what it's doing. It's actually now loading from the raw data into the typed table, so that's what it's doing at the moment. So we'll have to wait a little while for that. This more or less duplicates, of course, the amount of data that you have. So if you want to set up your jobs differently, you can do that. If you don't want to do these types of type checking and stuff on the way, you can do it on your way into the normalized data warehouse instead. You can do switch that refresh. Have a look every 5 seconds at this one and see what happens. So while we're waiting, we can start to look at how to model this. Oh, now it's actually done. So let's close this one and close that one and move back here into the golf stage. Now we should have some tables. So here you can see there's a raw split table and a type table. This is the raw data. This is where you have applied the data types. Everything seems to have worked quite well. So let's have a check and select the top 1000 rows from this one. So as you can see here, you have some columns with some data. What we will be interested in is, of course, the names, the dates, the statistics, and the actual value. But there are some metadata that is created over here as well. So for example, if you want to connect this back to the metadata, you can use this JBID, which is the job identity, and look it up in this job view over here. So you can see which job actually loaded this data. This is the container, so for every file it's finding, it's going to store it in this container anchor and attributes. So this is you can find information, the name, the type, when it was discovered, etc. So containers can also be tables if you're not working with files. But anyway, now we have this data loaded into the stage database. So we've successfully staged the data. The next step will actually be to load this data into a model in the normalized data warehouse. So we'll be building a small anchor model for that. But that will be in the next video, which will continue where we leave off here. Thanks.